Hello, everybody. Thank you for joining my session. We have, for information, a session plan change because yesterday we had technical problems in a session, Databaseless data processing. So Richard asked me to repeat this talk today because it should be more interesting and more important than the actual planned session. So this for your information. So this talk is about Databaseless data processing with EclipseStore. And here we have a huge promise. So I like to introduce you to how to create applications that are up to 1000x faster than traditional database applications, and at the same time save you more than 90% database costs in the cloud. And it's even simpler to implement with Java. So with this framework, which is open source as an Eclipse project, you can build incredible fast database applications. So if you have any questions through this talk, please use Slido. I guess you're familiar already with the process. This is a web app. You can insert your questions and we can answer the questions through the talk or in the end of the talk. If this not works for you, of course you can also interrupt me and ask questions, so we are not much participants here, so we can keep this also interactive. I have a small delay with here, the mouse. I show you, first of all, a performance demo that that shows and proves that incredible performance. So here are two applications running in parallel. This is a bookstore application, and by the way, the code is on GitHub. You can check this out and try to implement your own queries. Two applications are running. One application is built with the traditional JPA stack. Here we use a PostgreSQL database, 250 gigabyte. We use Hibernate as a persistence framework and JPA, EH cache as a local cache. And by the way, here we use a hot local cache, and we use Spring. And the other application is built with EclipseStore, just Pojos, pure Java approach, and we search and filter with the Java Streams API. And here we can see each query is around sometimes 10x faster, sometimes only 50x faster, sometimes 100x faster, sometimes more than 1000x faster than retrieving data from a hot cache. Okay. So, and I'd like to introduce you how this works and if you can use it for your own applications today. So about my background, my name is Markus. I am the CEO of MicroStream, which is the main contributor currently to the EclipseStore project. With my team, I've worked more than 20 years now on Java projects. We run various open source projects, 2 Eclipse projects with EclipseStore and Eclipse Serializer. We worked on more than 10 years on Java development environments. So we built a Java IDE. It's called RapidClipse. It's a kind of like Visual Basic for Java. And this was the initial project we started more than 10 years ago. We built 3 GUI builders, one based on Java Swing. Then, of course, JavaX came up, so we built a FX GUI builder. and then the HTML user interfaces became more popular. So we decided to build a new GUI builder based on Vardin. So 3 GUI builders, and they all worked fine. So they work like a graphics program. Everything was really simple to use. The problem was database programming was always too complicated. And for people who wanted to migrate over from any 4GL development environment like Oracle Forms or FoxPro or something like that, these people are still keen on migrating to Java because they know it's super powerful, great programming language, and support for decades. So, but it is too complicated. So they wanted to have an easy to use, today we would say a low-code development environment. So building UIs was simple, as I mentioned, but as soon as they wanted to show data on a screen, the horror began, because then we teach them to use Hibernate, and using the Hibernate tools which are available for Eclipse. And who of you, by the way, uses Hibernate? Okay. Nice. So if you use the Eclipse Hibernate tools, you import database tables to let the tool generate the whole entity classes, you get a lot of errors. It's because of the data types are completely different. So there are a lot of errors. You have to handle this. You have to map your data types. And our users were not able to do that. So we tried to improve the JBoss Hibernate tools at Eclipse. We developed around 6 years to improve it, to make it more simple, to make it faster. We included cache out of the box, cache configuration out of the box, to make it more simple. And in the end, we were not able to do it. It's because of the base problem is not, we were not able to fix it. When we tried to make it more simple, it became slower. When we tried to make it faster, it became more complex. And I like to talk a little bit about why, what are the problems, what are the reasons, and then we try to develop something completely different, which is pure Java, which is simple to implement, which is incredible fast, perfect for fast application development, and the end result is EclipseStore. And this was 10 years ago. This is about my background in Java. So the core problem is super interesting. All programming languages on the market, and of course also Java, and all databases on the market are incompatible from the technical perspective. Because of, in Java, everything is object-oriented. We deal with objects. Everything is an object. And as soon as we want to store data and we use a relational database, we have to deal with tables and relation and SQL. And it's not possible to store objects in a relational database. So we have various impedance mismatches here. So it's because of the Java object model is very flexible. So you can do everything in Java, of course. We can deal with all Java, with all types, with all data structure. So you can store values, a simple list. You can use collections. You can we have of course inheritance. We can deal with vectors, and databases. They provide a database specific data structure. They cannot deal with all of these data types we have in Java. This is really a huge problem. In my perspective, this is one of the biggest problems in the entire software industry. There are a lot of articles you can find on the internet about object relational mapping and impedance mismatches, what the problems are. And the initial idea of JPA was, We are dealing with objects, so we want to store objects in a database. Then we have the NoSQL databases. Who of you uses relational databases, by the way? Okay, and NoSQL? Okay. NoSQL is super interesting. So, because obviously relational databases are great, but not great for all use cases. They do not scale very well horizontally in the cloud. Dealing with unstructured data is not that great with relational databases. So we have various different NoSQL databases. Now, what's the biggest difference? I would say they introduce new data structure or data types, completely different model in comparison to relational. So here we have the column stores, the document-based, famous is of course JSON, key value stores, the graph databases, the object-oriented database in the 1990s. Interesting approach, because in the 1990s the object-oriented programming languages they became standard. So we want to store objects, so obviously we should create an object-oriented database which is able to store objects. This is obvious actually. But who of you uses object-oriented databases? Why not? So you use objects. Something went wrong obviously in the past. Then we have the time series databases. Now the vector databases are super popular because of AI. So, and very interesting is Java can deal with all this data structure, with all these data types. So this is the reason why Java is suited for almost all use cases. Because of we can build an IoT application dealing with sensor data, right? Not a problem. You can build an AI solution dealing with vector data. No problem. We can deal with graphs. Databases provide a database-specific data structure, so they are suited for a specific use case. And this might be the reason why the database vendors will tell you, hey, we provide you a graph database. If you have very complex data structure, this is suited. But if you have just sensor data, so probably a graph database is not a good fit. Please use a time series database, and probably a time series database vendor will tell you if you have very complex data structure, you should not use probably a time series database. So you need multiple databases. By the way, who of you uses multiple databases in applications? Okay, so which means you decide for one database that fits for all use cases. Yeah, we can do that. The question is, why are so many databases on the market? Believe it or not, there are more than 350 databases listed on DB engines, and it's only the databases are listed on DB engines. Probably there are a lot of more. You just need one. That's interesting. So, but the problems are solved, of course, because we do database programming all the time, every single day, and we use a lot of databases, so obviously it works. Who of you has performance issues? Okay, not that much. So you're great database developers. That's good. So because for relational databases, we have, of course, Hibernate or Eclipse Link. So we follow the JPA standard. Then we have object relational mapping. This is a great solution because now we were able to store objects in a database, in a relational database. So it seems like we can store objects. So everything is managed by the persistence layer behind the scenes. But here we have this object relational mapping. So you have to adopt your classes to the relational model, and behind the scenes we have this object relational mapping, which means if so SQLs are generated automatically by the framework, and vice versa, the database will never deliver objects, so the framework will generate the objects behind the scenes through every single read and write. And this is very expensive, so when we try to make it faster for our users, then we measured the queries, and we had a look on the performance tests of the database vendors, and they were mostly very fast. So mostly the database performance tests are fast. So the problem was, so we are wondering, where is the delay? So where are the latencies? And it's really interesting, astonishing that generating the objects takes milliseconds in any case. It depends on the complexity, of course, on the size of your result set, 10 to 100 milliseconds or even longer to generate the objects in any case, which means it never can be faster than milliseconds. Millisecond is very fast because of, for humans, but milliseconds are not fast for a computer. So even I showed the performance demo, and even when you read data directly from a hot cache, we have milliseconds. Who of you grow up with Commodore 64 and assembly programming? Okay, I also, great stuff. So I've learned if you have assembly instructions, they are executed in nanoseconds, even with a Commodore 64. And if you have a bad algorithm, it should be executed in microseconds. And when I saw that I fetched data directly from a hot cache, directly from memory, it takes milliseconds. What the hell is wrong? This is not super fast. So this is the architecture of an object relational mapping framework. It has to generate objects. A lot of things are done behind the scenes. The data have to be serialized into the memory and have to be deserialized by generating the objects. And this is takes milliseconds, and this is very expensive. So, but we can accelerate it. And to accelerate it, we can now add a local cache, and we'll make our architecture a little bit more complex. So we add a local cache. Then, of course, we have more challenges because now we have to deal with cache configuration. But okay, we can handle that. Who of you builds distributed applications? No one. That's great. Interesting. So many people tell me we have distributed applications, and by the way, who of you develops microservices? Okay. And you do not distribute the microservices? You don't scale it horizontally? Actually, with microservices, you should scale it horizontally to scale it out, and you have multiple instances of your service. So what's the problem with distributed systems? So as long as your system runs on a single machine, everything is fine, everything is simple. If you have a distributed system, it becomes super complex. Why? It's because let's assume there is one user, and he's delegated to one of these machines, and he changes data, buys something in an online shop, and now we store data back in a database. Everything's fine. So this machine, this node, and the database are in sync. The problem is if you have read access to all the other nodes, probably we have a eventual consistency approach. All of these, the other nodes are not in sync with the database, eventual consistency. So this might be a problem in some cases. But of course, we can now change our cache strategy. So what to do is we can now put our cache in between the application and the database. And in the cloud, we want to avoid a single point of failure, which means we need a distributed cache in between, like Redis. So we run a distributed cache cluster. And I show you these animated slides because of it shows that the complexity increases more and more. We run in more and more complexity. So if the load is very high on your database, and by the way, to run a cache, what do I need to run a cache? Memory. So at the booth, many people tell me we have to save money. So we run small memory machines to save money. But it makes no sense to run a cache cluster without memory. So you need a lot of CPUs, which means a cache cluster is expensive. If you have more load on a database, you probably need a distributed database. So replication in your database as well. Then you need a database cluster. So you have 3 layers, 3 clusters to develop, 3 clusters to maintain. And with microservices now, the complexity will explode. So with microservices, every single service is a distributed application, actually. And every single service should be able to scale out and to scale in depending on the load. So we have to manage various distributed systems. And sometimes a lot of companies, obviously database is not fast enough for searching. Who of you uses Elasticsearch? Okay. Hey, why? I mean, so you have a database. Database is built for searching. It's great for searching. Why do you need Elasticsearch? Probably sometimes the joins get bigger and bigger, and so executing joins is also expensive, takes a lot of time. Probably a searching server is more powerful than your database. So you add another system, you add another complexity, you need another machines, CPU, and a lot of costs. And then you can read all of these reports by Gartner. Why are the cloud costs skyrocketing? Here is one of the answers. Because of the complexity of our systems. And this is just for storing data. So initially we wanted to store data. This is the reason why, one of the reasons why our systems are so complex and so expensive. And there are another very interesting details. So with microservices, all the architects, the DevOps, they tell us, hey, please use stateless services, avoid state, small memory machines. We want to save memory. We want to save memory. We want to save money, of course, in the cloud. So please, no monoliths. So this was they are telling the last 10 years. And behind the scenes, look behind the scenes. What happens behind the scenes? Behind the scenes, we run database servers. What actually is a database server? It's a fat monolith because it's stateful. It runs constantly. Does your database need a lot of memory or no? Yes? A lot of memory. The more memory, the better. Because then you can avoid access to a disk drive. Why? Because access to a hard disk is very slow, it's expensive. Better have more memory. Everything is in a cache by the database. In a database cache, your access will be faster. Then you run a distributed cache probably in between. You need a lot of memory, a lot of CPU power, stateful machines. So on one hand, everything should be stateless, scalable, small, cheap. On the other hand, everything is stateful, expensive, and hard to manage. This is what we have seen the last years by customer projects. And databases are also very expensive in the cloud. Here's an example. PostgreSQL, 250 gigabyte at AWS. I know this depends on the size of your machine. Here's an example: 4 CPU, 16 gigabyte memory, costs you around $8,000 per year, just for one node. If you need high availability, data center replication, so then your price will double or triple depending on how many database nodes you want to run. But there's also a very cheap solution provided by cloud vendors. It's cloud object storage. And here we can see that storage is super cheap. So computing power is very expensive and memory. Storage is super cheap. 250 gigabyte AWS S3 costs only $70 per year. So more than 90%, more than 99% cheaper than any database in the cloud. And we do not talk about license fees. This is interesting because I know exactly, but probably they build object storage, which is also called binary blob storage, to store binary data, mostly files or images. The question is, can we use it also for storing application data? This would be interesting. And the answer is yes, we can use it also for storing our application data. And the cool thing is, with the database cluster, we have to care for everything for yourself, for scaling out, scaling in, replication, data center replication, backups. So this has to be maintained by you. Cloud object storage is maintained and managed by the provider. They provide you, they guarantee you uptime, they guarantee you backups, data center replication, just for $70 per year. So this is a great feature. I'm not paid by AWS, by the way, or any other cloud provider, but this is a feature. And then let's talk about the great features of Java. I love it to talk about the great features of Java. By the way, no, I'm sorry. I wanted to inform you we have Java t-shirts at the booth, but they are sold out. Next time. But why is Java great? So we have a great performance with Java because of the JIT compiler. So many managers, they think Java is not fast enough because they heard C++ should be faster or anything else on the market. But without JIT compiler, so I heard this from the Oracle architects, they say we can even outperform C applications thanks to our JIT compiler because it's accelerated and so the code is translated into machine code. So it's extremely fast and gets more and more faster during runtime. That's awesome. Not possible with a C program. So the question is, can we use this performance for data processing? And the answer is yes, absolutely. And another great information, we have the best data structure on the market. So the databases, they provide you database-specific data structure. They have to decide what data structures they should support and provide you. We have them all from the beginning. You can store single values. You can store sensor data in a list or in a collection. You can use collections, so like a key value store. We can create graphs. So very complex graphs, even better than the graph databases. Circular references, it's not a problem. We can deal with vectors. Everything is possible in Java. So we have the best multi-model data structure on the market. And the problem or a big challenge for all database vendors is they have to invent, because they run a database server, which means to query a database server, you need a query language. They all have to invent another query language. This is mostly a problem because this is native, it's a proprietary query language. It's not supported by Java. You need to wrap it with a Java API. Mostly This is not a database bashing, by the way, so this is my experience. Very often this do not work really well, so it's always a lot of issues. We have the best query language on the market, Java Streams. With Java Streams we can search and filter. Let's assume we have 1 terabyte memory. We have super complex object structure with circular references, whatever. You can search such an object graph with streams in microseconds. Microseconds, not milliseconds. Microseconds are 1000x, up to 1000x faster than milliseconds. So we can reach with Java in memory microsecond search time, query and search time. That's amazing. So now the question is, can we combine the power of Java with the low data storage costs of a cloud provider? Would that be interesting for you guys? 1000x better performance and 90% database cost savings in the cloud. Is this interesting for you guys? Yeah, thank you. Yes, it is. So, let's talk about EclipseStore. The functional principle is known for decades. And who of you works for a bank? No one. So I heard from a guy, he said, hey, it was interesting talk. We built exactly the same application, the same architecture for our high frequency trading application at, can't tell the name. And they built a high frequency trading applications where they can execute trades in microseconds, up to nanoseconds, because of it's mandatory. They cannot use a database and JPA stuff that takes 100 milliseconds to generate the Java objects behind the scenes. They build it in pure Java. The fastest application is a fat monolithic Java application, speed up by the JIT compiler, give it a terabyte memory, and then you can build a high frequency trading application, and you can earn $1 billion with Java. So the question is, can we use this for our business application? And this is the functional principle. Yes, we can do it. But the problem for these banks is they have to build a kind of like in-memory database for their own, because they can now search and filter with Java, but all of these functionality you get from a database server is missing in Java. So, but it's not the truth. So they have to build their own in-memory database system, and this is really expensive, definitely. And it's not suited for business applications. It's okay for a bank when you earn $1 billion with your application, you can do that. And it's the same with gaming companies. They use the same approach. There are gaming companies out there, they have 1 million players online, so a conventional database is not fast enough. So they build a huge monolith with a lot of memory inside, execute everything in memory, and the functional principle is called system prevalence. You can read about this in the internet. And the functional principle is really simple. So a lot of developers told me, I had the same idea 20 years before you had. So we load all data in memory, we search and filter in Streams API, and then, we need persistence. The only thing that's missing in Java, the only feature that's missing is persistence. Because of the databases were on the market before Java came up. So it was not mandatory to care for persistence. So you can use Java serialization, of course, to store your objects persistently on disk, but then you will run in a lot of further problems and other problems. And this might be the reason why only specific use case, only some companies use this approach to build their systems. But the last 10 years, we work on this approach and we have solved almost all of these problems. And at this point, I'd like to introduce you to EclipseStore, which is now an Eclipse project. It's open source. It's under EPL license, which means you can use it for commercial purposes. So you can build software products and use it in your company. It is already part of Helidon, which is a popular microservice framework driven by Oracle. It's part of Micronaut. So if you use, who of you use Micronaut? Not that much. Okay. We should change this. Who of you use Spring? All right. So we have also a Spring integration. Thank you. Okay. So it's integrated with the popular microservice frameworks, and here's the history of the framework. So this is not an experiment, or it's not a proof concept, something like that. This is a stable framework we use in practice or in production for more than 8 years. Not we, our customers, big companies. We can talk about some references like Allianz Insurance Company here in Germany, Fraport, which is biggest airport company in Europe, and a lot of other companies, and more use it in production for building their systems. So how does it work in a nutshell? So we have an object graph in memory. And the cool thing is now a database forces you to adapt your classes to their database model. This is not so cool. With EclipseStore, you can now design your object model freely. You can design your object model that fits for your use case. In more simple words, design whatever you like. We will be able to store it. So you can deal with all Java types. You can use circular references in your object graph. So everything is possible. We can store it. So we can store it by creating a binary representation of your object graph. And it gets stored persistently into any data store. So you can choose your data store, but it should be able to store binary data. So initially we used plain files. This is the simplest case, and it's, by the way, the fastest approach, because of it is almost the I/O operations have almost the speed of your hardware. So if you want to store 100 gigabyte data with a relational database, this will be challenging. If you store 100 gigabyte by using this serialization approach, will be very fast, because you have almost the speed of your hard disk drive. Very fast. So I/O operations are very fast, but you can also use the cloud object storages like S3. And then you have the benefit. It is super cheap in comparison to a database. You save more than 90% database costs in the cloud. So there are even, this is a little bit confusing, but I like to mention this. You can store your binary data even in a relational database. Why? It's because of a relational database can store blobs. And we had a big customer, they wanted to use EclipseStore, but they had a contract with Oracle. And then we developed we recognized, oh, Oracle can store blobs, that's great. Then we built a connector for Oracle, and now they can use EclipseStore for the performance and store the blobs in Oracle. Everything is happy. Everybody's happy. So this works also. You can choose the storage target, and we have storage connectors for the most of the popular databases on the market. If there is something missing, I'd like to invite you to contribute to the project. It's open source, or create an issue. Then we can care for the connectors. The functional principle is really simple. So we replace, in our architecture, we replace Hibernate with EclipseStore. Now we can store really native Java objects. And this is, by the way, the biggest difference to all databases. A database has its own data structure. We didn't invent a new data format or a structure. We store native Java objects. We keep data in memory. so our object graph is now our kind of like in-memory database, because we can search and filter with streams, so it's a kind of like in-memory database. It's already everything in memory, so we can skip the local cache. So no more complex cache configurations, can eliminate this complexity. So the architecture is very simple. This is a single node application, monolithic single node application. This is the simplest case. So the big question is, we saw the performance demo already. I have only a slide. Now the big question is, do I have to load the whole database in the memory? Because it sounds like everything is in memory. That's great, but do I want to load the whole database in the memory? No, you can do that. And by the way, it is recommended, so it will be fast, but it's not mandatory. I should have a slide that shows you that is not mandatory. So if you have a terabyte database size, you have a terabyte memory, load the whole database in the memory extremely fast. There are no I/O operations, and by the way, I/O operations are in any case the slowest part of the system. But if you have only 2 GB memory or 4 GB memory, it really works. And it even works with AWS Lambda if you have only 512 MB memory. Because of we have lazy loading. So this enables you to not load the whole database, can load only single subgraphs in the memory and restore single subgraphs in memory. And the cool thing is that the framework loads the object reference and merges the object reference directly into your object graph. So there are no more object copies. Everything happens on your object graph. This approach runs, the framework runs wherever a JVM is available from Java 11. It even runs on Android. We have the same implementation for Android. Who of you develops Android application, Android apps? No one? Okay, we have sometimes customers, they, at Fraport for instance, if your luggage gets scanned at the airport at Frankfurt, this is an Android app developed by us. So they use we use EclipseStore to store data at the local phone and to synchronize data with the Java server. It runs in Kubernetes clusters. By the way, here we have Java 8. This is the older version. The latest version now runs with Java 11. It even runs with native images, GraalVM native images. You can use EclipseStore even with GraalVM native images. Runs in Kubernetes pods, as I mentioned, wherever a JVM is available. It runs also with JVM languages, and here are some database connectors. So the cloud vendors are supported, and you can also store your objects in Kafka, for instance. So this is possible. EclipseStore is just a Maven dependency. It's a very tiny Java library, has no dependencies. Dependency to JDK is the only dependency. There are no requirements to your classes. That's also very cool. So you don't have to implement serializable. So I mentioned serializing. So we serialize the changes of your object graph and create a binary and store it, append it to the file storage. But we do not use the Java serialization for that. It's because of a lot of developers had the same idea, but there are too many challenges with the Java serialization. Java serialization is very insecure. Please ask Steve Poole. He's here at the conference. He's an expert. And he can show you how to hack a JVM very easily, by the way. And so it's insecure, and it's slow. It is cannot deal with very complex object graphs. So the depth of your object graph is limited. and you cannot store and restore subgraphs with the Java serialization. And there are further challenges like what is if my classes change? So schema migration is not covered by any serialization framework on the market. So we built a new serialization framework from scratch. It's called Eclipse Serializer. It's also open source and available as an Eclipse project. You can use it for any purpose you need. If you need a serialization framework, check it out. Maybe it's a fit for you. This is the core of the EclipseStore framework. And by the way, this is the only dependency that EclipseStore has. So Eclipse Serializer is the core of the framework. So how does it actually work? You don't have to implement serializable. You don't need any other interfaces, no superclass, just poachers. So no specific requirements to your classes. And by the way, you can store any Java types, not any, so any types that can be recreated. So you cannot recreate a thread, something like that. This is not possible to store. Makes no sense. So you need an instance of create an instance of EclipseStore. You create a root object. Who of you is Swing developer? No one. So this is 20 years ago, I know. Have you ever created a J tree? Yeah, awesome, nice. So the J tree, we have the root object, and then we can add further objects. And this works pretty much the same. We need a root object, and now we can add some objects. Now we create an instance of a storage. And now, okay, I add some objects here. So everything is animation here. So I add an object, and now I have to call one store method. That's all. Create a store method, store the object, and the serializer will create a binary representation of my object and will store it in a file storage. And each store is a new file in your file storage. So let's add some more objects, and now you can add complexity, add circular references. Everything is possible. So call another store method and get another file in the file storage, and so on. And it's the same with changing objects. If you change data, we store it, and it creates another binary file in the file storage. We never overwrite data in a file storage. Every new store appends a new file to the file storage. This sounds like a problem. It is not. The file storage will grow more and more, but we have a kind of like garbage collector for the file storage to clean up the storage behind the scenes. So what happens when you start your system? This is very interesting. Then EclipseStore loads, so we create a root object, and then the framework will load the whole object graph in the memory, but no data. Only the object IDs are loaded, so you get a fully indexed graph in your memory, no data. And now you can decide whether your object should be eager or lazy, or your classes are eager or lazy. So it's your decision. If you want to build a microservice and you need fast startup time, everything should be lazy. If you build a huge monolithic application, you start it once and runs for a week or two or a year, then you can load everything in memory or much data in memory. Then you can define it as eager. So, and then we load data lazy in the memory, and then no more data is loaded in memory. So this is the reason why we can deal with a gigabyte memory. That's fine. And only when we touch an object, then the object reference is loaded into memory and is merged into your object graph. So only when we call a get method. So this fully object-oriented. There are no more classic selects. Next speaker is waiting. We have some minutes left. Okay, so fully object-oriented. No more classic selects. So it's easy to test, easy to maintain, and the only thing is you need a wrapper clause for defining classes as lazy. That's it. And it's the same with the deleting objects. And there's only one rule. Only please store the object that has changed. So if you change an object in the, I'm sorry for that. You have to change. You have to store the object that has changed. If you store, if you change an object in a collection, then you have to store the collection. This is the only rule. It's object-oriented, but there are some problems sometimes because of developers think object-oriented, but mostly not in terms of data. Mostly they think relational. So we have also a distributed approach. We can replicate the system state through hundreds or even 1,000 JVMs. So we can build distributed systems very easily. You don't have to, there's no different programming model. It's just a different kind of deployment. We support it, provide a fully hosted version as well as an on-prem version. And so this is the reason why you can also build distributed applications. If you're interested in EclipseStore, we provide you free trainings. So you can enroll for free trainings. And if you register at our booth, you will get access to the advanced trainings as well. They are fee-based, but you get a code and you can enroll for free. The code is on GitHub. You can find everything on EclipseStore.io. So check this out. You can build extremely fast applications with Java. JVM performance is deciding. It will save a lot of costs of infrastructure, and hopefully it's a fit for you. Check it out. Give us feedback. Yeah, have a great day at JCon, and thanks for joining.